A simple message can change everything. A few words on social media can make the world stop and listen. This happened recently. A top leader at Google DeepMind posted a short message. He said, AGI, Artificial General Intelligence, is now on the horizon. 4 words that sent ripples through the tech world. Conversations exploded. Big questions followed. Are we truly that close? It felt different from the usual hype and speculation. The feeling was electric for a reason. This wasn't a distant observer. It came from the heart of research. A signal from inside one of the most advanced AI labs on Earth. The long-theorized future is moving into our present. Many timelines we held might be wrong. It was a wake-up call. The moment we've discussed, read about, and watched in movies is entering reality. AGI is becoming a near-term engineering problem, not distant sci-fi. You could feel the first tremors. When a signal cuts through the noise, you have to ask, who sent it and why now? The messenger matters. In this case, it's Shane Legg, co-founder of Google DeepMind, and its chief AGI scientist. This isn't a casual observation from the sidelines. He lives and breathes the AGI mission, steering one of the world's most advanced research labs. He sees the breakthroughs, the dead ends, the capabilities and limits firsthand, long before they become public knowledge. Decades of dedicated work give his words a specific gravity. When a seasoned captain, who has navigated these waters for years, says he sees land, you listen. He knows a cloud from a coastline. But words are one thing, actions are another. Then came the action. An unusual role opened right after the tweet. Not for another AI researcher, but for a senior economist. This position would report directly to Shane Legg, embedding economic strategy at the very heart of the AGI team. The mandate: build a team to study the economy AGI. They would be modeling labor displacement, productivity explosions, and the necessary policy frameworks for a world fundamentally reshaped by this technology. You don't hire a hurricane preparedness team for a storm predicted in 2075. You hire them only when it's forming just offshore. This is a commitment of money and resources, a clear declaration of intent. It signals a shift from theoretical research to practical preparation. This action gives context to his forecast, a 50% chance of minimal AGI by 2028. 2 years. That's close. Close enough to feel tangible, to demand immediate planning. To be clear, minimal AGI doesn't mean a superintelligence. It means broad, human-level competence across a wide range of cognitive tasks. It might still lack consciousness, self-awareness, or genuine emotional depth. It would be a powerful tool, not necessarily a new form of life. But even at this minimal level, it would profoundly transform work, accelerate science, and redefine the global economy. This isn't a new, sudden prediction. He's held this line consistently since 2009. For over a decade, his timeline has remained steady. That consistency matters. It suggests his forecast isn't based on hype, but on a long-term, data-driven model of progress. To gauge the frontier of AI reasoning, evidence matters. And recently, a system called Alpha Geometry provided a stunning piece of evidence by tackling Olympiad-level geometry. This domain is a classic benchmark for human intellect, a space where logic and spatial intuition must elegantly intertwine. For decades, it has represented a formidable challenge for artificial intelligence. These aren't simple textbook exercises. They are problems designed to require profound insight, genuine creativity, and the construction of elegant, non-obvious proofs. They test the very ability to see hidden connections and forge new pathways to a solution, something long considered a uniquely human skill. In a landmark result, Alpha Geometry solved 25 of 30 past international mathematical Olympiad problems. This performance is near the level of a human gold medalist, a benchmark that many in the field thought was still years away. The breakthrough came from a hybrid approach. It combined a neural network's intuitive pattern recognition with a symbolic engine's rigorous, step-by-step deduction. This synergy allowed it to discover crucial construction steps that unlocked otherwise intractable proofs. This wasn't just brute force computation scaling up, it was a qualitative leap in reasoning behavior, a glimpse of an AI that can generate its own path to insight. To researchers who struggled with these very problems as students, this achievement hit hard. The feeling was palpable. We're getting close to something fundamental. Yet, for all the progress, crucial missing pieces remain. The path to AGI isn't a straight line. We still see major gaps in deep reasoning, hierarchical planning, long-term memory, and the capacity for true invention. Today's models excel at short, self-contained tasks, but they are still weak on long, multi-step projects that require a strategy to adapt and evolve over weeks or months. A core reason is that LLMs don't yet keep a robust, evolving memory of the world or of their interactions with you. Their context is powerful, but fleeting. Building persistent, integrated memory is a major focus of active research. Systems using vector databases and retrieval augmentation are early steps, but a truly integrated long-horizon memory architecture is crucial for AGI. And then there is the hardest ask of all: genuine invention. Could an AI look at the universe of data and discover new laws of physics the way Einstein did? Could it invent whole new games with emergent complexity, or formulate entirely new mathematical or philosophical theories from first principles? This is the leap from interpolation to true extrapolation. Still, the frontier is advancing relentlessly. Systems like Google's Gemini are pushing multimodal breadth, integrating vision, language, and audio to build a richer world model. Meanwhile, OpenAI and others showcase staggering capability gains in coding, visual understanding, and the first steps toward autonomous agents that can use tools to accomplish goals. The evidence ladder of capabilities rises higher each quarter, but a few critical high-level rungs remain just out of reach. That's why a date like 2028 feels plausible to many insiders, not as a guarantee, but as a reflection of the current trajectory. It feels close enough to be taken seriously. This is the key point for understanding this moment. Stunning, tangible progress, paired with an honest accounting of the gaps, creates a potent mix of caution and wonder. We're stepping into a new phase, where the abstract questions about AGI are becoming concrete engineering problems. The race to AGI isn't a single event, but a persistent, high-stakes summit. Multiple teams are on the field: Google DeepMind, OpenAI, Anthropic, and a growing ecosystem of well-funded challengers. Each is a formidable contender, pushing the boundaries of what's possible. They operate with different philosophies, incentives, and timelines. Some are structured as for-profits, driven by market demands. Others are rooted in public benefit charters, attempting to balance progress with societal good. This creates a complex dynamic of cooperation and intense competition. The timelines reflect this divergence. Some insiders are bullish, hinting we are just months away from the next major leap. Others, like Google DeepMind's Demis Hassabis, urge patience, suggesting a handful of years are still needed. But everyone agrees, a few hard breakthroughs still matter. These aren't minor tweaks. They are fundamental problems in areas like long-term memory and autonomous reasoning that must be solved to reach the summit. Public interviews offer trail reports, but the ultimate proof is the technology itself. This fierce competition accelerates innovation, but it also dramatically raises the safety stakes. The pressure to be first is immense, but it cannot justify being reckless. The climb to AGI demands discipline, radical transparency about capabilities and risks, and robust technical and institutional guardrails. Measured, verifiable progress is what builds public trust. It's the clear signal that cuts through the noise of hype and fear. The right posture now is a dual state: profound caution paired with profound wonder. On-screen text, caution plus wonder. Amidst the technical signals, a strategic one stands out. Hiring an economist is the clearest clue of all. It signals a shift in focus from, "Can we build it?" to, "What happens when we do?" If the cost of intelligence drops towards zero, the foundational assumptions of our entire global economy begin to shift. Cognitive work, the engine of the modern middle class, will be fundamentally redefined. The historic link between human labor and economic value may decouple at a scale we've never witnessed. This isn't a distant academic problem. We will need new frameworks for wealth distribution, taxation of automated systems, and a reimagined social support network. This conversation must be serious, global, and it must move fast. The technology will not wait for policy to catch up. The signals are all aligning. The insider tweet, the near-term forecasts from credible sources, and the visible breakthroughs in capability. The horizon is no longer a faint line in the distance. It is rapidly coming into view. It's time to prepare.